So in this example, we have to find the complex conjugate of the product of two complex numbers, 2 plus 3i times 3 plus 2i conjugate. So remember, a complex conjugate, right, takes a complex number, a plus bi, we're using the asterisk, to get a value of a minus bi, where a and b are real numbers. So we have to find the complex conjugate. Now, if z1 and z2 are complex numbers, and I find the complex conjugate, it's z1 complex conjugate z2 complex conjugate. If I have z1 divided by z2 complex conjugate is equal to z1 complex conjugate over z2 complex conjugate. So in this example, we just have to evaluate 2 plus 3i times 3 plus 2i complex conjugate. So we could go through the process of going through this evaluation of complex conjugate of both elements, which I'll actually do. So in this case, it'll be 2 plus 3i complex conjugate and then replace 2 plus 3i with 2 minus 3i, 3 minus 2i, and then perform an expansion. Or the simpler solution is that we could actually just say that replace all i's with minus I instead. So it's a faster way of doing things. So in this case, the complex conjugate of the product is nothing more than 2 minus 3i times 3 minus 2i. Replacing all i's with minus i's. And then we can perform an expansion of 2 times 3 minus 2i minus 3i times 3 minus 2i, a distribution expansion. So 2 times 3 is 6. Is it on the board? Yeah, it's still on the board. Minus 4i minus 3i times 3 is minus 9i. Minus 3i times 6 is plus 6i squared. And we can get the I squared is minus 1. So I'm going to write the next line as 6 minus 4i minus 9i minus 6 plus 6 times minus 1. Notice the 6 disappears and we're left with minus 4i minus 9i is minus 13i. Is it on the board? Yeah, just barely made it.